8 developers saw your branch and origin main have diverged after a teammate reset main and force pushed. One merge later, duplicate changes hit production. Here's exactly why. Let's break down Git Reset. Hard, soft, and mixed explained how it works and the exact mistake behind that failure. Git Reset moves the current branch pointer to a specified commit. It's the primary tool for undoing local commits. The 3 modes control what happens to the changes in the commits you're undoing. Soft keeps them staged, mixed unstages them, and hard discards them entirely. All 3 modes move head and the branch pointer. The difference is what happens to the staging index and working directory. Soft keeps everything staged, mixed clears the index but keeps files, hard wipes both. Let's set up a test repo with 3 commits so we can see each mode in action. A soft reset moves head back but leaves all changes staged. This is perfect for squashing multiple commits into one clean commit before pushing. Here we undo the last commit with soft. The changes remain staged, so we can immediately recommit with a better message. A mixed reset, which is the default, moves head back and clears the staging index. The changes remain in your working directory as unstaged modifications. Here we do a mixed reset. The changes are now unstaged, so we can selectively stage parts of them before committing. A hard reset is the nuclear option. It moves head back and discards all changes in both the staging index and working directory. This is the only mode that can permanently lose uncommitted work. Here we do a hard reset. The commit is gone from the log, but we can recover it using the Reflog. The Reflog records every movement of head, so we can jump back. The key distinction: Reset rewrites history by moving the branch pointer, while Revert creates a new commit that undoes changes. Reset is for local cleanup. Revert is for undoing changes on shared branches. Here's the difference in practice. Reset moves the pointer back. Revert creates a new commit that undoes the last commit, and you push normally without force. If you accidentally run a hard reset, committed work is recoverable for 30 days via the Reflog. Uncommitted changes are gone forever. Always run git status before a hard reset. To recover, use git reflog to find the commit hash before the reset, then create a branch pointing to it. This restores your lost commits. This is the same issue we highlighted at the start. Here's exactly why that happened. The developer ran git reset hard head ~5 to undo a bad deploy, then force pushed. But 8 teammates had already pulled those 5 commits and built feature branches on top. Their local history now pointed to commits that no longer existed on remote, causing divergence. The root cause was using git reset hard on a shared branch, main, and force pushing, which rewrote history and orphaned commits that teammates had already pulled, causing divergent branches and merge chaos. The fix is simple: use git revert instead of reset. Revert creates a new commit that undoes the bad commit without rewriting history. Push normally, and teammates pull a clean fast forward. No divergence, no lost work. Never hard reset a branch that others have pulled. The force push rewrites history, causing every teammate's local repo to diverge. This is exactly what caused the 8 developer 2-hour outage. Using reset on a shared branch and force pushing breaks every teammate's local repository. They will see divergence and have to manually recover. Always use revert for shared branches. If you have uncommitted changes and run a hard reset, those changes are gone forever. The Reflog only saves committed work. Always stash or commit before a hard reset. The article states that committed work is recoverable via git reflog for 30 days. However, the default expiry is 90 days for reachable commits and 30 days for unreachable ones, configurable via GC, reflog expire, and GC, reflog expire unreachable. On CI or shared machines, garbage collection may run sooner, reducing the window. If you staged changes before a hard reset, they may be recoverable as orphan blobs. Run git fsck unreachable grep blob to list them, then use git show blob hash to inspect and git hash object w to restore if needed. The article mentions branch protection rules as a recovery step. In production, enforce them proactively. On GitHub GitLab, enable restrict deletions, and require linear history to prevent force pushes and non-fast-forward updates on main. This makes Git Reset hard on shared branches impossible without admin override. To debug reset issues, start with Git Reflog to find lost commits. Always run Git status before a hard reset. If the working tree is dirty, stash first. For shared branches, use Git Revert instead of reset. Let's run through some common interview questions. What is the difference between Git Reset and Git Revert? Reset rewrites history by moving the branch pointer. Revert creates a new commit that undoes changes. Which mode of Git Reset discards changes? Hard discards both staged and unstaged changes. How do you recover from a bad Git Reset hard? Use Git Reflog to find the lost commit hash and reset to it. And a few frequently asked questions. What's the difference between soft and hard? Soft keeps changes staged. Hard discards all changes. How do I undo the last commit without losing changes? Use Git Reset soft head -1. Can I recover uncommitted changes after a hard reset? No, uncommitted changes are permanently lost. To recap, Git Reset has 3 modes, each controlling what happens to your changes. Only use Reset on local branches. For shared branches, use Revert. The Reflog is your safety net for committed work, but uncommitted changes are lost forever. Always run Git status before a hard reset. Ready to go deeper? Up next, Git fetch versus pull. What's the difference, then Git amend? Edit the last commit, then Git init, creating and initializing repositories. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.